How we doing? Just like the other one, right? Yeah, you good. Deep breath, it's okay.
It's not bad.
It's not that. If you got the formula, not that bad, right? So we got same formula, right? Heat equals MSH delta T. Uh-oh. Where do I get specific heat from? From the table. You gotta know that? Well, you gotta know it to solve the problem, but you don't have to memorize the table, right? Let me give it to you, right? Fair enough? Okay.
Wait. Yeah.
I'm just curious to write the numbers in. I'm not changing it yet. Deep breath. 175 grams. Specific heat was what? 0.897 joules over grams degrees C. Delta T, 95 degrees C. How many joules is that? 14,800. 900 what?
12.
Joule equals 15 kilograms. The 2 sig figs. Okay? A little bit of problem solving skills.
Oh, wait.
Do like I do, circle stuff in a problem. Mark out stuff that's not important, right? Is it important it's aluminum? Yeah? Because if you don't know it's aluminum, you're not going to get the right specific heat. Okay? All right. Well, what are we going to do with all these heats and stuff? We're going to change states. We're going to go from North Carolina to South Carolina. Maybe Virginia. Who wants to change states? You're happy in here?
No.
You like this class? Okay. How do we change states? If you have ice and you want to make it liquid water, what do? You got to put some heat in it. Well, what if you have liquid and you want to make it ice? What do you got to do? Do what?
Take heat away.
You got to take heat out of it, don't you? Okay? So it's all about heat flow. Okay? Heat in or heat out. Now, when something changes from one state to the other, it's just called a change of state. And you see they have like a little triangle up here. We're going to talk about that triangle in a little bit. The most common one that you guys think about is melting and freezing, right? Melting is going what? Solid to liquid. Freezing is going liquid to solid. Now, if we have water, at what temperature does ice melt?
32.1? 0 degrees.
Ice melts at 0 degrees Celsius. At what temperature does it freeze? All right, it melts at 0. Y'all tell me it melts at 0. What temperature does it freeze?
I want to speak in English.
Why is that hard?
0 is the same for both.
It's the same for both. Thank you. Because you're going, they can't both happen at the same temperature, aren't you?
No, I'm not. I've heard it. That's something we learned a long time ago, right?
It happens at the same temperature. I often have students tell me, well, you can't do both at the same temperature. It's got to be warmer than 0 for it to melt. No, it does not. They both happen at the same temperature. What is different between whether it's freezing or melting.
What
You're
you're-
adding heat or you're taking heat out. They're both at 0 degrees Celsius. Okay? So if I give you a question and it says, at what temperature does water melt? You better not tell me 0.1 degrees Celsius, because that's not true. 0 degrees Celsius. Okay? At what temperature does it freeze? 0 degrees Celsius. Same thing, right? Okay. I say that, some others are still going to tell me wrong. Okay. Now that temperature at which this happens is different for every substance, right? Does ice and butter both melt at the same temperature? No. They have a characteristic melting or freezing point, don't they? Butter is higher than ice. I don't even know what butter is, but I know it melts easily, right? Okay. So, this is called the freezing point or melting point. Same temperature, just different direction. Heat in or heat out. For water, it's at 0 degrees Celsius. Now, we have an equation that we can use for this. Heat equals mass. Oh, I don't even put on here. This is called the heat of fusion. How much heat does it take to melt 1 gram? Or how much heat do you have to take out to freeze 1 gram? Okay? Because that amount of heat's the same. It's just, is it going in or out? Mass times heat of fusion will tell us how much heat do you need to melt something. And if you don't know what it is, there are tables of it, right? For water, it's 80 calories. It's 80 calories per gram or 334 joules per gram. These two numbers are the same, they've just been converted, right? 4.184. So this is in your book, handy number to know. You don't have to memorize it, just know where to find it in your book, right? So here's a question. How many kilojoules are needed to melt 32 grams of ice at 0 degrees C? I'll give you the equation again. Heat equals mass. This is easier than what we were doing before, isn't it? Mm-hmm. We only got to know 2 terms here. Do we know the mass?
Yes.
What's the mass? 32 grams?
Yes.
So we got to know this term right here. And where do we get that term right there? 334 joules per gram. Oops. What happens? Grams cancel, and I'm left with joules. How many joules is that? 32 times 334 is?
1,068.
No.
That's
10,000.
That's kilojoules.
Well, I was going to convert, I just did
10,600.
10,688.
convert to
Then we want to convert to kilojoules, 3 sig figs, 10.7 kilojoules. One more. All we gotta do is multiply 2 numbers together. This is easier than what we were doing before, isn't it? So this says it would take 10.7 kilojoules to melt 32 grams of ice. Well, if you had 32 grams of water at 0 degrees C, how much heat would you have to take out to make it freeze?
Same.
10.7 kilojoules. Same amount. Okay? Just a different direction, in or out. Now, there's another process. So that was going from a solid to a liquid. Well, what about going from a liquid to a gas? That is a process called evaporation or vaporization, okay? When the liquid reaches the boiling point, it will all turn into a vapor, into a gas. True? In lab this week, you'll see that once it gets to the boiling point, the temperature doesn't change anymore. It stays constant until it's all evaporated. Okay? The molecules are gaining heat and are turning to a gas. Gases have lots of energy. The reverse of that is condensing, when it goes from a gas to a liquid. All right, we're getting ready to get a little bit like PG-13 rated. Who watches Moonshine? Anybody watch the show Moonshiner? They have a condenser, don't they? What's the condenser do on the still?
Contains the liquid and it drips down.
It condenses it, turns it from a gas back to a liquid, so they can then collect it, right? Did y'all know that that's why they had a condenser on there? You knew what it was doing? You got a still in your backyard? Huh? If there's a jar with clear liquid in it sitting up here one day, I'll know what you're doing. More commonly, do you ever see water vapor condense?
Yeah.
When?
When you take a shower,
Yeah, it could be
in the bathroom on my mirror.
on the mirror, right? The steam in there hits a cold mirror and it condenses, forms little water droplets. I was thinking about something more relaxing.
Oh,
Sitting outside on the deck in the summertime with our iced tea. What happens to your cup? We call it sweating, don't we? If you grew up in the South, that's what you call it, right? But it's not really sweating, is it? Because sweating implies that like when I sweat, the water comes out of my skin, right? Is that water that's on the outside of your cup coming from the inside of the cup?
no. It can't go through the cup.
It cannot go through the cup, can it?
No.
Everybody believes that, right?
It doesn't.
Okay.
Yeah.
I've had people before swear that it's doing that. I'm like, so if you leave your cup sitting there, all the water's just going to come flowing out of your cup to the side. You go back and store by yourself a new cup, right? Well, where's that water coming from on the outside of your glass then?
In the air.
There's water vapor in the air, right? When it's humid, that's water vapor. Why does it condense?
Heavy.
Why does it condense?
Because the cool liquid inside the glass makes the heat around the glass lose energy and cool off.
The water vapor loses its energy, loses its heat to the glass, and then it doesn't have enough energy to stay as a gas. It got tired, turned into a liquid. It condensed. We get liquid condensation falling from the sky, don't we?
Yes.
What's liquid condensation?
Right.
Rain.